A welding arc flares briefly against a dark mountain wall, bright enough to be seen from the opposite ridge. Seconds later, a rifle report echoes through the ravine. The engineers do not scatter. They lower their heads, wait for confirmation from overwatch, and return to work. Before dawn, this span must carry armored vehicles across a frozen chasm, or an entire battalion remains cut off beyond the mountains. The ravine sits at high altitude, carved deep by seasonal meltwater, and now hardened by winter. Sheer rock faces drop into a narrow channel choked with ice. The only existing bridge was destroyed days earlier, leaving a Philippine Army battalion isolated on the far side. Air resupply has been limited by weather. Ground reinforcement depends entirely on a structure that does not yet exist. The engineering unit arrives after nightfall to reduce visibility from surrounding ridgelines. Headlamps are used sparingly, filtered to minimize glare. Equipment is unloaded by hand to limit noise. Each movement is deliberate. They understand that light travels far in thin mountain air, and sound carries even farther across frozen rock. The mission is straightforward in concept and complex in execution. Install a modular steel bridge capable of supporting light armored vehicles and supply trucks. Anchor it into permafrost and fractured stone. Complete the work before first light exposes the entire site. There will be no second attempt if the position becomes untenable. A forward element of Scout Rangers has already secured elevated observation points. Their task is overwatch, not engagement unless necessary. Through optics, they scan for movement along likely sniper positions. The valley appears still, but stillness in contested terrain is rarely reassurance. It often means someone is watching. The first steel girders carried to the edge of the ravine by 6 engineers moving in coordinated silence. The span will rest on prefabricated bearings designed for rapid emplacement. Measurements are confirmed with handheld laser rangefinders. There is no room for misalignment. Even minor deviation could compromise load distribution once vehicles begin crossing. When the initial drilling begins, the pneumatic hammer echoes sharply through the gorge. Within minutes, a single round strikes the rock face several meters above the team. Dust falls in a thin sheet. No one shouts. The hammer stops. Overwatch respond with controlled fire toward a suspected firing point. The engineers wait, then resume. Anchoring steel into frozen ground demands precision. Drill bits overheat quickly in dense rock. Engineers rotate tools to prevent mechanical failure. The lead non-commissioned officer checks anchor depth personally, brushing away debris with gloved hands. He knows that a shallow seat could shear under torque once armored weight rolls across the span. Portable ballistic shields are positioned around welding stations. They are heavy, imperfect barriers that offer partial protection from direct lines of sight. Welders kneel behind them, aware that the brief flash of their torches may attract attention. Each seam must be continuous and clean. A rushed weld is not an option. Across the ravine, the isolated battalion monitors progress over encrypted radio. Their vehicles remain concealed under camouflage netting. Fuel levels are calculated hourly. Ammunition is rationed carefully. Without the bridge, their maneuver options are limited to foot patrols along exposed slopes. The engineering effort is their only reliable exit. A second volley of shots cuts through the valley, closer this time. One round strikes a partially secured girder, ringing sharply against steel. The impact does not penetrate, but shifts the alignment slightly. Work pauses again. The lead engineer assesses a displacement with a flashlight shielded by his palm. He orders the girder reseated before welding continues. 2 soldiers adjust the support using manual come-alongs, applying gradual tension to restore proper alignment. It is slow work, measured in centimeters. Overwatch maintains steady surveillance, reporting no confirmed visual on the shooter. The valley returns to uneasy quiet. Temperature drops further as midnight passes. Breath becomes visible in steady clouds. Gloves stiffen. Fine motor control diminishes. The welders rotate in short intervals to maintain steady hands. Fatigue is acknowledged but not discussed. Everyone knows the timeline. Dawn will arrive whether they are ready or not. Engineering calculations are reviewed repeatedly. Load capacity must exceed the combined weight of a light armored vehicle and its cargo, with margin for uneven distribution across the deck. The team confirms bearing plates are level. A small error at the base could amplify stress across the entire structure. Another welding arc flashes, followed by a delayed rifle crack. This time, a round strikes a ballistic shield, denting its outer plate. The welder behind it does not move immediately. He waits for the signal from overwatch before shifting position. The shield is replaced within minutes, work continuing without visible panic. The psychological strain is cumulative. Remaining stationary while aware of unseen observers requires discipline. Engineers focus on procedure to steady their breathing. Measure, align, weld, inspect. The repetition becomes a form of control in an environment defined by unpredictability. By the third hour, the primary support beams are in place across the ravine. Temporary decking allows limited foot passage for inspection crews. The chasm below reflects faint starlight off frozen surfaces. The drop is unforgiving. A misstep would mean more than injury in this terrain. Scout rangers report a possible thermal signature shifting along a western ridge. Suppressive fire is delivered in short, controlled bursts. The intent is deterrence rather than escalation. The exchange remains measured. Neither side commits fully, but the message is clear. The bridge site is defended. A support column near the far bank requires deeper anchoring than anticipated. The soil composition differs from initial assessment, containing fractured stone beneath the frost layer. Drilling takes longer, and time is no longer abundant. The lead engineer recalculates anchor spacing to maintain structural integrity. Radio traffic from the isolated battalion grows more frequent as first light approaches. Enemy movement has been detected farther east. The window for extraction may narrow once daylight fully exposes the valley floor. The engineers increase their pace, but not at the expense of accuracy. Deck panels are maneuvered into place using rope systems and coordinated lifts. Each panel must lock securely into the support frame. Bolts are torqued by hand and checked twice. There is no opportunity for post-construction correction once vehicles begin to cross. Pre-dawn light softens the horizon, outlining the ridgelines in pale gray. Visibility improves rapidly. Smoke grenades are deployed along the near bank to obscure direct observation without disorienting the work crew. The valley fills with low haze, diffusing shapes and movements. Incoming fire increases briefly as silhouettes become easier to distinguish. A round chips concrete from a newly set bearing plate, but causes no structural damage. The team maintains formation. Overwatch answers selectively, preserving ammunition while discouraging further precision fire. The final span is guided into position with steady hands. It slides forward, steel grinding softly against steel until locking pins drop into place. The sound is solid, unmistakable. For a moment, the entire team pauses to verify alignment across the full length. Load calculations are reviewed one final time. The bridge is not elegant. It is functional, reinforced where necessary, efficient in design. The lead engineer signals completion to command. Authorization is granted for a controlled vehicle test. A light armored vehicle approaches slowly, engine noise restrained. Its driver aligns carefully with the center of the deck. The first set of wheels rolls onto the steel surface. Every eye follows the subtle flex of the structure, searching for irregular movement. The bridge absorbs the weight as designed. There is minor deflection within predicted tolerance. The vehicle advances steadily, crossing the midpoint and reaching the far bank without incident. A second vehicle follows, confirming stability under sequential load. With the span validated, the isolated battalion begins stage movement across the ravine. Vehicles cross in intervals to avoid concentrated stress. Personnel move alongside, maintaining perimeter security. The bottleneck that defined the valley hours earlier is gone. As daylight strengthens, hostile fire diminishes. Whether by repositioning or decision, the opposing marksmen withdraw from the immediate engagement. The engineers remain until the final vehicle is crossed, conducting rapid inspections for any structural compromise. By mid-morning, the ravine no longer separates the force. What stood as an impassable obstacle overnight has become a controlled passage. The achievement is not dramatic in appearance, but it is decisive in effect. Filipino combat engineers balance physics, discipline, and composure under pressure, ensuring movement where there had been none.